out. And then, okay, so what we have actually, because we've been working in with factoring x squared plus things like x squared plus 2x plus 3, things like that, we are ready to begin the process of graphing them and understanding all the things that had an x squared in it that we've been working on. Not all of them, but a lot of them. They are parabolas, and we need to learn how they work on a graph. You guys are going to get really good at this, And usually this is the kind of thing that ninth graders don't learn very well. They freak out when they have to graph, and I have these awesome little tricks on graphing. Unfortunately, you won't see them today, but eventually you will see them. But let's just remember what a quadratic equation actually is in terms of a formula. This is the formula: y equals ax squared plus bx plus c. Where this is a number, this is a number, and this is a number. The x squared and the x stay as x's and the y stays as a y in your equation. Like for an example, you might see y is equal to 2x squared plus 3x plus 5. That would be an example of a quadratic equation where there's a number there, a number there, and a number there. The ones that I have been giving you so far have not had anything in front of the x squared, which means there was a number, but what was that number? 1, right? Right? So I was giving you things like this: y is equal to x squared plus 2x plus 1. And I said factor them, right? So you've been factoring them. Now, today we're going to skip this middle term. We're going to get rid of the middle term. And we're only going to deal with graphing things that have the ax squared, where a is 1, and the c, okay? So this is what we're going to graph. Y is equal to x squared plus 2. Actually, you know what? Let me start off. Y is equal to x squared. Let's start with that. This is the most standard, most basic quadratic equation you can get. That's about it. And we're going to use a t-chart. X, y. When you use a t-chart, when it's a quadratic, when it's a straight line, you would normally do 0, 1, and 2. Does anyone remember that? We talked about that a long time ago. It would, for a straight line, I always choose 0 as my first one, and then 1 and 2, almost always. But for a quadratic equation, you need to have 5 points instead of 3 points. So you're going to have 0 down here. You're going to have -1, -2, and then 1 and 2 in this case.
Oh, yeah, I remember that.
What? You remember this?
Yeah.
And so the reason you have to do this is because you have to see where it turns around. And you'll see what I mean in a second. So what we're going to do is we're going to actually plug each of these into this equation. So if y is equal to x squared, if x were -2, right, I would just put in -2 squared. What's -2 times -2? 4. Positive 4. Okay, good. All right. If x were -1, I would put y is equal to -1 squared. What's -1 times -1? 1. All right. If x is 0, y is 0 squared, what would y be?
1.
0. 0 times 0 is 0. And then if x were 1, y is equal to 1 squared, right? And that would be 1 times 1 is 1. And if y were 2, if x were 2 squared, 2 times 2 is 4. Okay, now notice on the left side, on the x's, we have -2 and we have a +2. Notice the y's for -2 and +2. They're the exact same thing. Right? Yes, question?
So isn't it like when you grab it, it would be like this or like that or something?
Yeah, exactly. It's because the squared Whenever you have a squared, it doesn't matter if x is positive or negative. It's always going to give you the same positive answer. You see what I mean? Because squaring something would be two negatives times, negative times a negative. It becomes a positive. So you're going to have exactly the same thing in the y. Same thing for the negative one and the positive one. They both give you a positive one for the y. And the 0 gives you a 0. This, where the y is 0, in this case, it's a turnaround, okay, point. So if we were going to graph this, these are actually points. You think of these just like a coordinate point. That's the same as this, -2, 4, right? And that's the same as -1, 1. But I don't bother writing this because this is it's already here. You know what I mean? These are coordinate points. So I'll just use them as they are. So it says -2, 4. So I'll go over 2, and I'll go up 4, and I put a dot. And then I've got -1, 1, -1, 1, put a dot. 0, 0, put a dot. 1, 1, 1, 1, put a dot. And then 2, 4. 2, 4. And then I could draw my parabola. Now it is never this. It is never this. Just so you know, it's never a V. It's always curved. V is a totally different, this would be y is equal to the absolute value of x. That would give you a V. Okay? There's no squared, so there's no turning thing. Well, there's turning things around because it's absolute value. But anyways, it's going to always be curved. It's going to be a parabola. Now, notice some things. Let's notice some things. This, how far is this from the y-axis?
2.
How far is this from the y-axis?
2.
2. Isn't that interesting? And how far is this from the y-axis?
1.
1. And this? 1. This line here, where 0, 0 is, where this is called the vertex, right here. That right there is called the vertex. And wherever that vertex is, if you drew a straight line up and down from that vertex, you would have this. This is called your axis of symmetry. Axis of symmetry, okay? So I'll be writing this down because you need this stuff. Axis of symmetry. And why would they call it the axis of symmetry? What does symmetrical mean?
Means like the same. Yeah.
Same what?
Also, 2 things that are the same or yeah.
Yeah, sort of like a mirror image almost, right?
Yeah.
Like each side is going to be exactly the same, symmetrical as the other. If you cut them in half, if you fold a paper in half, right, then you have it, you open it up, they're symmetrical, right? Exactly, like Oliver just did. Yeah, exactly. Both sides are symmetrical. So the cool thing about that is if I know where the vertex is, then I can just plot one side, and then I can say, oh, well, this is 2 over from the axis of symmetry, so I just go over 2 this way. Does that make sense? If I know this is 1. So I could have plotted this. I could have graphed it like this. So I knew, okay, so I know I could just plot these, 0, 0, 1, 1, 2, 4, and then I could have said, oh, well, I know this is my vertex, therefore this is over 1 from my axis of symmetry. My axis of symmetry is always the vertical line that goes through my vertex. So I could have immediately gone over 1 again, over here. Over 2 again, over here, and I could draw it like that. Make sense? You see that? Now, notice this. This is my equation. What if I added a c? Let's say we're not going to put a something x. We're just going to add a c. What if I said plus 3?
Then you would go up 3, and then you would just add x.
So right. So I mean, if I was using the t-chart, then I would just have to redo my t-chart, right? and I'd do -2, -1, 0, 1, 2. And then I would have now a different, I have -2 squared plus 3, -1 squared plus 3, and then 0 plus 3, and then 1 squared plus 3, and 2 squared plus 3. Okay, what would this give me? -1 squared is
1.
4, right? Plus 3, right? Would be
Oh, yeah.
7, right? 7, and then 1 plus 3 is 4. 0 plus 3 would be 3. 1 plus 3 is 4 again. 4 plus 3 is 7. And then I could graph that. And then if I graph that, where was I? Okay, so -2, and then 7, boom, and then -1 and 4. 1, 2, 3, 4, and then 0, 3, 0, 3, boom. Now, I've plotted this side. I could keep following these, or I could say, well, this is over 1, I could go over 1 here. This is over 2, I could go over 2 here, and then just draw my graph. You with me? Make sense? That's all we're going to do today. And then I'm going to, once you've got this down, I am going to talk about the anatomy of this equation, because there's things that if you understand it, most people don't understand this at all, but if you understand what each of these things do to a quadratic equation, it will be so simple for you, so simple. And that's something that's so seldom taught. Yes? Yes. All right, so I think for now that's it. Notice if let's just look at one last thing. Notice when I had y is equal to x squared plus 0, right? That other one, it had a c of 0. Look where it ended. Look where it ended at 0, 0. I mean, where the vertex is, right? For y is equal to x squared plus 3, look where the vertex is. At 3 on the y-axis. This 3, this c, or this 3, or this 0, these are the y-intercepts. That's really cool. That way you can always tell. So where do you think the y-intercept is going to be if I said y is equal to x squared minus 5?
At -5.
At -5. 1, 2, 3, 4, 5. I know it's going to start there. I know it's going to start there. Does that make sense? See what I mean? Y is equal to, x squared plus 6. Where's it going to be? At 6, right? 3, 4, 5, 6. That's going to be there. I know it's going to go up like that. I know this is going to go up like this. So as you use the T-chart, you'll start to see that. And then tomorrow I'll show you a shortcut. Okay, as long as you understand that that's your y-intercept, the shortcut will work very, very well. Okay.